Hey there, guys and gals. It is time for our third lesson of Algebra 2. We're going to be continuing on our review journey by looking at factoring polynomials. We're going to kind of rapid fire several different topics here. We're going to hit kind of several different factoring bits and all of those things. And well, let's just dive in. So the first example we're going to look at is if we have what's called a GCF, right? So GCF stands for what? Well, GCF stands for don't die as you choke on whatever. No, it stands for greatest common factor. Right, so we're looking for, as we look through all the different terms. Now, if you'll remember that when we're talking about terms, we're talking about the little product parts, right? So anything that's divided with addition or subtraction, or anything that's split up by addition, subtraction, right? So those are the terms, right? So we're looking at all the different terms and seeing what's in common. Well, in this case, we have a 5 that goes into both of these two numbers. So we're going to write down everything that's in the GCF right here. Okay. So a 5 goes into both of those. Now, what else do they have in common? So you got to look at the letters as well, right? So they both have at least one X in them, right? So we put an X out there. Then once we have our whole GCF, which we have, we do an open parentheses. Then what we do is we write down what's left. And just to review this topic, I won't always write this little intermediate step here out in an Algebra 2 class, in the future. But since we're in the kind of our review section, I want to make sure we remember what's happening here, right? So we're dividing each term by the GCF is what we're actually doing to get what's left over. So when we take 5x squared and we divide it by 5x, then the 5's cancel and one of the x's cancel. And we're left with just an x. Right, and bring down our minus. Don't forget all your symbols and all your things. Watch those negatives. They'll get away from you if you're not careful, right? So we're gonna take this and divide it by 5x. 25 divided by 5 is 5, and x divided by x just makes those x's cancel. Right? So that is that. It's very simple, very straightforward. Right? Let's take a look at another one. This one is going to be our first trinomial. Okay, so we're trying to factor a trinomial. Remember I say remember, if you for whatever reason have entered this class and you've not factored before at all, or you're like really, really, really rusty, it would behoove you to go and watch the Algebra 1 videos on this topic. I can link them either in the iCard or the description or something, as long as I remember, which I'm kind of in the workflow I have right now. I think I should remember. Either way, you can find my videos or other people's videos on factoring trinomials. I've got a couple of them, and then there's lots of others too. Okay, so if you remember, back to what I was saying, if you remember, our first step on factoring trinomials is really easy, because our first step is just to do two sets of parentheses. Open, close, right? And then you remember the way, at least the way I teach it, if you're coming from my classes, there are essentially two slots. There's the front, there's the first, and then there's the lasts, right? So there are two slots going on here. So for the first slot, what we want to do is we want to do two things that multiply to get this first term. Now, these first couple examples are just going to be x squared or a squared or whatever. And so it's going to be really easy, because what two things multiply to get x squared? Well, just x and x. No big deal, right? Once we add a number up here that's not just 1, then it gets a little bit more complicated. We're going to do some examples like that soon. So then you want two things that multiply to get 12. Now, it can be helpful, especially as you're just learning and continuing to practice factoring and all that kind of stuff, if you kind of list out the factors of this last term over here, right? So what can we multiply to get 12? Well, we can do 12 and 1, 6 and 2, and 4 and 3. We can, of course, reverse the order on these as well. 1 and 12, 2 and 6, 3 and 4, all of those. We don't have to list out every single one of those forwards and backwards. The order will matter soon. It doesn't matter on these problems yet, but it will matter on when we have a number that's not 1 right here, right? And so going back to this, we need to pick some numbers. So I'm going to pick 4 and 3. Now, make sure, especially now, the more practice you get, the more you'll be able to do this easier. But especially as you're continuing to practice this, make sure you're doing these with pencil because you're going to guess wrong. This method that we're using here is called guess and check, and you're going to guess wrong. It's just gonna happen. It's kind of like when you're balancing chemical equations in chemistry or whatever else, where you've got to try stuff and see what happens and then work out from there, right? So after we've got our guess, we're going to check. And the way we do a check is we do a smiley face, right? So we're going to do a smiley face. There's our nose, there's our mouth. And then we multiply along the smiley face. 4 times 1 is 4. Remember, if there's nothing there, there's an invisible 1. 1 times 3 is 3. Now we are trying to either add or subtract these numbers to get the middle number. In this case, that is -8, right? Okay, so can we either add or subtract 4 and 3 to get -8? Well, you can't, right? Because 4 plus 3 is 7, -4 plus -3 is -7, and then we subtract them and we get some variation of 1. It doesn't work. So this is what I'm talking about, right? Now, I actually, believe it or not, did that on purpose because I wanted to make sure you see how to guess it and check it and find one that's wrong and go from there. So if we guessed wrong, then we're going to take with our eraser because we're using pencil, right? And we're going to guess again, right? So this time, let's put, how about 6 and 2? 6 times 1 is 6. 1 times 2 is 2. Can we add or subtract those to get -8? Well, yes, we can, because if we put a negative right here and a negative right there, then we get -8. -6 plus -2 is -8. So follow our nose and put our sign, and follow our mouth and put our sign. That would be the same in this case, right? You couldn't have messed that up if you tried. You could mess it up if you tried real hard, I suppose. But yeah, anyway, there it is. That's that one. Let's do one more that's kind of like that. I like to make sure we have plenty of examples. And this one, actually, I picked for a very particular reason. This one, I won't spoil the ending. So our first step was what? Our first step was 2 sets of parentheses. Easy peasy, right? Open, close, open, close. In the first slot, we're going to put X and X. What are our options for 6? Our options for 6 are 6 and 1 and 3 and 2, right? So let's take a look at this. We're going to put 6 and 1 first. We do our nose and we do our mouth. And we're doing 6 times 1 is 6. 1 times 1 is 1. All right, so we're trying to get 5. Can we get that? 6 and 1, can we get 5? Yes, we can. We put a minus here and a plus here. 6 minus 1 is +5. Perfect. A-okay. So we're going to put a plus right here and a minus right here. Now, what if I told you that this doesn't actually work? So this works for the middle term, but there is one more thing, and I didn't say it on the last example because I wanted to wait and not spoil the punchline for this example. But we have to check one more thing at the very end, and that is we need to check the sign for the last term. 6 times -1 is -6, which is not what we want, right? And so this doesn't actually work. Even though it works for the middle term, it doesn't work for that last term. So you got to double check that sign at the very end. That is the one step that's easy to forget and easy to make a little mistake at the very end. So let's check with our other option. So let's put 3 and 2 instead. 3 times 1 is 3. 1 times 2, I don't know why I erased the 5, but there it is. 1 times 2 is 2. 3 plus 2 is 5. Both positive. Works out great. Follow our nose. Plus, plus, and 3 times 2 is +6. That works great. That's finished. Okay. All right. Let's do another one. This time, we've got one where this number in front of the x squared term is not, in fact, 0. That would be a totally different thing. It's not, in fact, 1, right? And so we've got, it's going to be a little bit harder. Scam likely. Let's ignore that. How about? All right. Okay. open, close, open, close. Now this time we have multiple options for this first term, which makes it a little bit more tricky. So for 6, we have 6 and 1 and 3 and 2, right? And for 3, now for the 3, we only have one option, which is great. And here is a free bit of advice. If either one of these has only one option, go ahead and put that one in place and leave it there. That way you have the thing that's guaranteed set up, and then you're just checking the other bits, right? So let's put a 3 and a 1 right there. So what do we want to try? Well, we can try 6 and 1, or we can try 3 and 2. Let's try 6 and 1. How about? Let's do it. So 6x and 1x, right? There we go. So we're going to do our nose and our mouth. Nose, mouth. 3 times 1 is 3. 6 times 1 is 6. Can we add or subtract those to get a positive 7? No, we cannot. Now, this is important. Before, and again, just like I said a few minutes ago, the more you practice these, the more you may be able to kind of see to the end a lot quicker. Like I mentioned the other kind of other science example there, or it's similar with like balancing chemical equations. The more you practice, the more you can see to the end easier. But more than likely for most of this, you're going to have to try once or twice on some of these, right? Especially these where this is not a 1. So we tried 6 and 1. And what my other piece of advice here is, before you move on to the other numbers, try changing the order and see what that does. So let's do 1 and 6 instead. 3 times 6 is 18. I can already tell that ain't going to work because we're going to get a 1 out of the next one, right? So that's not going to work. All right, so instead of 6 and 1, let's try 3 and 2. How about 3, 2? Okay. 3 times 2 is 6. 3 times 1 is 3. So does that work? Well, no, we can't either add or subtract those numbers. So we've tried all the numbers. Oh, wait, remember we can change the order and see what happens, right? So before we give up and say, this is just not factorable, why'd you give me a stupid problem? Let's do 2 and 3 instead, right? 2 and 3. 3 times 3 is 9. That's really close. 2 times 1 is 2. Look at that. It works. Because if we do 9, positive 9, and negative 2, then we're good to go, because that gives us 7. So we follow our nose up, and we put a plus right here, and we follow our mouth and put a minus. There it is. Let's do another one of those. We're getting close to being finished here. We're doing great on time. Now, this one did for another. Remember I said at the very beginning of this video that we're kind of reviewing a whole bunch of little concepts all in one. So this one, we're going to combine a couple of things. For this one, we have a GCF first, right? There's something that goes into every single one of these terms. So the first thing we want to do, the very, very first thing we want to do, is we want to pull a GCF out. So what goes into 8, 40, and 50? 2 does, right? So let's pull a 2 out. So we're going to pull a 2 out. We divide 2 into this. We end up with 4x squared plus 20x plus 25. All right, so now we pulled out a GCF. Now, the question that always gets asked is, well, what happens to the 2? Well, he just hangs out there. He just lives there until the finish line. Just don't forget to continue to bring him down. So we're going to put our 2 down, and then we're going to do our next step just like we've been doing every time. We're going to do open, close, open, close. We need 2 things to go into the first term. Again, we have 2 options. We have 4 and 1, and we have 2 and 2. For 25, we have 25 and 1, and we have 5 and 5, right? Similar looking thing. Let's just go for broke, and let's try 2 and 2, 5 and 5. Why not? Who knows? May work, may not work. This is how you do these, right? And this is important. And this is why if we were in person, I would, I'd call on somebody and we might luck into the right answer. And this one, I don't even think about it, right? I don't look at my notes over here that's got the answers, because I want to make sure you understand that we're trying stuff and seeing what works. erasing it if it doesn't, and trying again. That's the way to do these when you're first learning. You'll get better and better. So let's start with 2x and 2x. That's two things that multiply to get 4x squared, right? Last term, how about 5 times 5 gives us 25. Seems great, right? 5 times 2 is 10. 2 times 5 is 10. We're trying to get 20. It works. Double check our last sign because they're both positive. All works great. There it is. What happens to the 2? Remember I said he just hangs out. So he's a part of the answer, just over there hanging out. We have 2 more examples. These last 2 are super easy because what we have here, these are both similar. There's one that's just, the next one is a little bit more complicated, but not really. What this is a difference of 2 squares. I'm going to go ahead and write that out. Difference of 2 squares. Right? So it's a difference, meaning subtraction. And then 2 perfect squares. What are perfect squares? Let me remind you that. Again, we're in review mode. Want to make sure we get all the little bits and bobs in our head. So perfect squares are things where we end up with like 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16, etc. Right? Continue on going. Same thing with the variables. X times x is x squared. X squared times x squared is x to the 4th, etc., etc., etc. Right? So when we have a difference of 2 perfect squares, to factor it, it is really, really easy. You start out with 2 sets parentheses, right? We don't even have to guess and check this time. We just kind of, there's just straightforward steps. Here we go. 2 sets parentheses. First lot is the square root of the first one. The square root of x squared is x. So we have x times x is x squared. Second slot is the square root of the second one. Square root of 4 is 2. And then our signs are plus and minus, and that's all there is to it. Blam, done. Peace out, right? Let's do one more of those to make sure you got it. This because I added a little bit of ugliness looking. Okay, so we actually have a difference of 2 squares again here, right? So we have 2 perfect squares and we have a difference. So what were our steps? What did we just do? Well, 2 sets parentheses. Square root of the first in the first one. What's the square root of 16? Well, 4 times 4 is 16. So square root of 16 is 4. What's the square root of y to the 4th? All right, so the square root of y to the 4th. Right, so right now, depending on your previous background now and whether you've learned about rational exponents and all of that other nonsense or not, we're going to learn about that at some later in this class. But whether you've learned about that, what all you really need to think about right now is what times itself equals this one. Well, if we do y squared times y squared, remember we have like bases multiply, we add the exponents. And so it gives us this. So the square root of y to the 4th is y squared. All you really do is divide this exponent by 2, by the way. That's kind of the shortcut way of thinking it. And then we've got plus and minus. You know, I should have done this different, but that's okay. I should have made it to where you could actually factor it more out, but that's fine. We're in the review version. We'll hit that when we actually get to some of these lessons in the bulk of this course. All right. So now the square root of 49. Well, 7 times 7 is 49 is 7. 7 times 7 is 49. So 7 goes right here is what I'm trying to say. There it is. And that's it. And that's our last example for this video. Hope it's been helpful for you. If you're one of my students, I'll see you in class. Do your homework and all of those things. If you're not one of my students, thanks for joining us. Let us know how else we can help you with your math, your science, or any other stuff, general homeschool learning, all those things. Thanks and have a great day. Bye-bye.